Okay, in 5-2, we're going to talk about factoring trinomials. So we just talked about factoring things by grouping, and we talked about factoring just simple binomials. So just a little review. If we had something like this, and we wanted to factor that, our common factor would be a 3x. That would come out and leave us with y plus 2. So that's what we were doing on the last lesson, and we will get a review of factoring by grouping as we factor trinomials. But I want to look at a trinomial first as to how we multiplied the binomials. So for instance, if you had these, and this is two binomials being multiplied, and we've kind of covered this already before, you could either look at this like a double distributive. So you draw your first hump, that's n times n, which is n squared. The second hump would be n times negative 9, which is negative 9n. Excuse me. Then this one, the 8 distributes, so 8 times n is 8n. And then when you distribute that 8 to the negative 9, that becomes a negative 72. So if you look at that for just a second, the middle terms are like terms and they will combine. So we simplify that to be n squared minus n minus 72. Okay, so I want you to notice, where did this term in the middle come from? And where it came from were those two middle terms. And the coefficient is really a negative 1, because our coefficients when we started were a negative 9n and an 8n in the middle. And we combined negative 9 and 8 to get negative 1. Well, let's look back over at our original problem. And I want to see exactly where those two terms came from when we started. So the negative 9n came when we multiplied those two outside terms together. It gave us that one. And then the positive 8n came from when we multiplied these two inside terms together, and it gave us that one. Well, if you look at this even closer, when we multiplied the last two terms together, that's where we got our constant. So the constant on the end has a relationship to the two middle terms. The factors of 72, the 9 and the 8, also contribute to our middle term, because 8 minus 9 combined to give us a negative 1n. So if you keep that relationship in mind, you can always go from n squared minus n minus 72, and you can work this whole thing backwards. So what we need to look at, I'm going to go ahead and erase this one because I want you guys to get used to seeing it without a coefficient. When we're faced with factoring a polynomial that is a quadratic polynomial, and remember quadratic means it's a second degree, so your lead term has a coefficient, an exponent of 2. The first thing we look at is our constant. And we want to ask ourselves, what are the factors of 72? Now we've been looking at getting the prime factorization where we draw the factor tree. It's not what we want here, we just want two things. Well, you can multiply 1 and 72 together. And you can multiply 2 and 36 together. And you could multiply probably 3 and 24, there we go. And I don't know about 4, 5 I know won't go, 6 might go with 12, 7 won't go into it, but 8 certainly will, 8 times 9. That's most of the factors of 72. Now if I look at these factors, now I'm going to concentrate on my middle coefficient. The middle coefficient is a 1. Now remember, to get the middle term, we combined like terms, and when you combine like terms, that's addition or subtraction. So could you get to a -1 by adding or subtracting 1 and 72? And if you did 1 minus 72, you could get to -71. 1 plus 72 would be 73. 72 minus 1 would be 71. And 72 plus 1 would be 73. None of those combinations will give you what you're looking for, which is a -1. So the same process with 2 and 36, you could get to 34 or 38. Never could you add or subtract those together in any fashion to come up with a -1. 3 and 24, by adding or subtracting a variety of different orders and signs, you could come up with 27, 21. Never would you get to a 1. 6 and 12, you could get to 6 or 18 by subtracting or adding. Never to 1. But 9 and 8, to get to a -1, would be 8 minus 9, right? And that's where we're trying to get. So we now know that we have a -9 and a +8 in our binomial, because remember, when we multiplied these two things together is where we got our 72. And since our 72 is negative, we need one negative and one positive, which comes in handy because the only way to get to the -1 is to have a -9 and a +8. And then the first term, because the coefficient is 1, is easy to separate. It is n times n. And remember, if you're going to double check this, you do your double distributive. So n times n is n squared. N times 8 is 8n. -9 times n is -9n. And -9 times 8 is a -72. Combine the two in the middle and it turns into n squared minus n minus 72. And that is exactly what we started with. And that is exactly how you factor it. So let's look at our worksheet, which is mistitled, it's titled 5.3 Factoring Trinomials, but we need to do it before we do special cases. So we are going to look at 5.3 Factor Trinomials, knowing in the back of your mind it's actually 5.2. So let's look at number 3. Do not be mistaken, we did not do number 1 just now. It looks a lot like it. That is not number 1 that we did. So do not think that you can choose B on number 1 and move on, because that is not going to work. So when we start with x squared plus 12x plus 32, and we want to factor it, well, it's pretty easy to get that first term because it's an x and an x. Now 32 has some factors. 1 and 32, 2 and 16, 4 and 8. I think that's about it. So where am I trying to get to now by adding them? I multiply these to get my constant, but I also add them to get my middle coefficient. Well, this top one would get me to 33 or 31, but not where I want to be, which is 12. The middle one I could get to 14 or 18, but not where I want to be, which is 12. But 4 plus 8 is definitely 12. And since the product needs to be positive, they either both need to be negative, because negative 4 times negative 8 is 32 positive, but also positive 4 times positive 8 is positive 32. So I have two possibilities here. Well, negative 4 plus negative 8 is negative 12, and 4 plus 8 is positive 12. Look at the problem and you'll see we need to get a positive 12. So that tells me both are positive. And when you want to double check this, do the double distributive. X times x is x squared plus 8x plus 4x would give you 12x plus 32. And that is exactly what you started with. And that is exactly how you factor it. So we first look at factors of our constant, and then we looked at the factors of our lead term, which in this case was easy because it was a coefficient of 1. So if you look down at number 12, 12 gets a little stickier because you have coefficients on your lead term that are not 1. And so let's look at this for a second. Possibilities to get this first term could be a 5x and a 2x, but it could also be an x and a 10x, couldn't it? Okay, well 54, that's a pretty big number. Factors of 54 are 1 and 54, 2 and 27, 3 and 18, 4 doesn't go in, 5 doesn't go in. I give up on 6. Now let's see. 6, 9 times 6 is 54. 7, I think we're good. 8 doesn't. So we have 4 possibilities. Okay, well let's look. Let me move this x and 10x out of my way for just a second. I'm going to just put this down here. So I can't just look at these and try to figure out how to get to 96, because let's just take the last one for instance. You see, when I multiply 5x times 2x, that gets me my 10x squared. But because of that 5, that 9, 5x times 9 is a 45x. And 6 times 2x becomes a 12x. And then, of course, the 54. So here, when I try these combinations, 6 and 9 is being multiplied by either 5 or 2. So it becomes a 45 and a 12. There's a little more depth to these with a combination out front, with a coefficient out front. And also, if you were to rotate those, 9 times 6 is still 54, but your possibilities would be 30x, and I'm just pretending we're all positive here for fun. And then you would have an 18x from the inner term. So see, this top one would give you a 57x, and the middle one would give you a 48x. So you would have to try every single one of these 2 times here. But look, there was a second combination. You have to try those 2 times there as well. That's a lot of combinations and a lot of opportunities to either mismultiply or misadd. So let's go all the way back to the beginning. And let's notice something about these numbers. They're big for one thing. Big coefficients are where you get all those possibilities of parentheses. Is there a common factor there? I know there's definitely a 2. Let's bring the 2 out. Now when you do that, your lead coefficient is prime, so the only opportunities to get 5x squared are going to be 5x and x. And remember, with the 10, we either had 1 and 10 or 2 and 5 out front, which caused us a whole new set of tries or combinations to see if they worked. Well, now we just have the 5x and the x. We immediately cut those numbers in half when we got rid of the 10 out front. Now let's look at factors of 54. Well, you can get to 54 by using 1 times 54. And you can get there with 2 times 27 and 3 times 18. And then you could get there with 9 times, I'm sorry, we're not doing 54. I hope you guys caught that. We factored that out. We're looking at 27 now. That is why we factor things out, is so that those constants will be smaller. Now let's look at factors of 27. 1 times 27 and 3 times 9. And that's all we have. So if you remember with the 54, we had a whole list over there of things that we were trying with possibilities. And because we have a coefficient here, we can't just simply say that the top one is either 26 or 28, because we're going to be multiplying one of those times 5. And that's going to change the things that we get when we add our products. So let's take the 1 and the 27. Well, if we were to multiply that out, 27 times 5 would give us 135x. And then the 1 times the x would give us an x. There's no way we're going to get to 48x when we combine those. Now, if you notice, I'm ignoring these outer terms right now, because I know already 5x times x gives me my first term, and I know 27 times 1 gives me my last term. So I don't really need to consider those possibilities. All I care about are the outside pieces and the inside pieces, because their products combine to give me this middle term, remember? Okay, so definitely that combination doesn't work. But what if we switched the 27 and the 1? Now we would have 5x and 27x. We're trying to get to 48. Will that get us to 48? It could be 22x, or it could be 32x, but never 48. Therefore, 1 and 27 is not going to work. So now let's try the 3 and the 9. And there is no trick here. This is exactly how you factor these. Hopefully, you recognize something and the answer comes to you more quickly. But if not, we're forced to do trial and error. So 5 times 9 is 45x, and 3 times x is 3x. Well, 45 plus 3 is definitely 48. Let's look at the bottom one just to see. 5x times 3 is a 15x, and 9 times x is a 9x. There is no way you can get to 48x by adding these two together. Therefore, our answer must be the 3 and the 9. So now I want to look, is the product that I'm trying to reach positive or negative with my constants? And it's positive, so that would be a positive 3 and a positive 9. It could, however, be a negative 3 times a negative 9. Both of those give me positive 27. So now I'm going to look at my middle term. My middle term needs to be positive. Well, if I had a negative 3 and a negative 9, that would give me a negative 45x minus a 3x, which would be a negative 48x. When you multiply that, that's not going to work. Therefore, our answer will be the positives. Now you notice there was a 2 out front the whole time that we were doing that. That 2 was factored out from our original quadratic expression so that we would have smaller coefficients so that we could factor it in a reasonable amount of time. That 2 will simply stay with your answer and come right down. And if you were to multiply that back out again, you could distribute the 2 first and then distribute to the second binomial, or you could do your double distributive, just like we've been doing, and then multiply all 3 by 2. So there's 2 ways to double check that, and either way will work because order of multiplication makes no difference. That is the correct answer, so you can look on your worksheet for number 12 and see that the answer is B. So when you're factoring quadratics, your first thought is to look for a common factor if you have a lead coefficient that is not 1. If it's 1, you're usually pretty easy to factor that. But if it's more than 1, try to find something common and factor that out, just like we did with the 2 on that one. Because you want smaller numbers, smaller coefficients, so that you have less choices over here. And then that's less parentheses you have to check to see if they make the winning combination. But let's look at one that has a lead coefficient that's not 1, and there are no common factors, and let's look at another method to do this. This is number 23 on page 2. So if you look, our lead coefficient is 9, and there's no common factors here between 1, 8, and 9, so we're stuck with that. And what that means is you could have a 1 and a 9, and you could a 1x and a 9x, but you'd also have to flip-flop that because that makes a difference. Or you could have a 3x and a 3x. And you would have to try every one of these combinations with 2 and 4 and 1 and 8. That's a lot of work. Well, there is a method called AC method. And if you'll remember, you may have forgotten this, quadratics, when they're in standard form, are in the form of ax squared plus bx plus c. The a is the coefficient to your lead term or your second degree term. Well, the AC method uses your A and C and multiplies them. So let's look at our A and our C. A is 9 and C is 8. I don't care about this sign right now. Well, A times C is 9 times 8, which is 72. Well, if I look at the factors of 72, that's going to be 1 and 72. It's going to be 2 and 36. 3 and 24. 4 and something. 4 and 18. Yes. And then 5 and 6 will go in there. 6 times 12, and then 8 times 9. Okay, so this is kind of like what we've been doing, but I promise you it's going to be easier. Okay, where are we trying to get to? A -1. I don't really care about the 9 at this point. I realized when we have the lead coefficient on the last example, we could not simply go to our factors and look for sums. With the AC method, we can. So which one of these products, factors, when you add them up, will give you a 1? 1 and 72 will not. That gives you a 71 and a 73. Excuse that puppy. Or you can get a 6 and an 18 out of 6 and 12. With the 2 and the 36, you could get 34 and 38, 21 and 27, 22 and 14. 9 and 8 is how you get to 1. So with the AC method, what you have to remember is rewrite and expand the middle term. So it turns into 9x squared plus 8x minus 9x minus 8. Now, if you look at that, does this indeed equal what we started with? Are these equivalent expressions? Does 9x squared minus x minus 8 equal 9x squared plus 8x minus 9x minus 8? And yes, it does. If you were to combine like terms in the bottom, they would be equal. So you haven't changed anything. You've just rewritten the original expression. Now I'm going to look for common factors by grouping. Well, if you look at the first and the third term, they both have a common factor of a 9x. And if you look at the second and the last term, they both have a common factor of an 8. So let's regroup that so that we have 9x squared minus 9x plus 8x minus 8. Don't put your middle terms back together yet. And remember on the last lesson, when we regrouped these, so I'm going to put the 9x squared and the 9x together, and I'm going to put the 8x and the minus 8 together. And now I just want a common factor between those two. So in the first set, I could take out a 9x, leaving me with x minus 1. And on the second set, I could take out an 8, leaving me with x minus 1. Now I have a common factor within that group of x minus 1, which I will take out. And that leaves me with 9x plus 8. And if you were to multiply that out using the double distributive, you would end up with exactly what we started with, and that is factored correctly. So you have two options. You can use the AC method, and it will work for any quadratic expression, whether or not you have a lead coefficient of 1 or 100. It's going to work every time, and you don't have to try all those parentheses. You can use all the parentheses if you want as well. That's absolutely fine. You will get the same answer regardless. So let's look at number 24. So number 24 says, will you turn that light on for me? Mason, will you turn that light on? Negative 24 x squared plus 105x minus 36. Okay, now with this one, if we were going to try parentheses, we would look for a common factor first thing, because these are just too big. The numbers are too big. And especially, even with AC method, if you take 36 times 24, good grief, that's a huge number. Well, I see right off a 2 will come out, and there may be some more. That's not going to work. A 2 will not come out of 105. So I wonder if a 12 will come out. I wonder what... 12 is not going to work either. 9 will not work. 8 will not work. 7 will not work. 18 will not work. It looks like we're going to have to do this with the big numbers. So if we take 36 times 24, that's going to give you 824. So A times C is 824. Now let's split that up. So on your calculator, you're going to do 824, and you're going to divide it by things. Clearly, if you use 2, let's say 2 times 412, that is not even going to get you close to 105. So you're going to have rather large things to make this work. So if I were in your shoes, I would take any way I could to increase the first one and decrease the second one and get them closer together. So if I was doing this by 4, it would be 4 times 206. That's not going to work. Or it would be 8 times 103. Now if you know what I did, I doubled the first one and half the second one. And it still comes up to be 824. I haven't really changed much. Well, definitely, I think 103 and 8 is getting close, because where am I trying to get to? 105. So is there a way to combine 8 and 103? Not quite there yet, are we? So let's just keep on going with what we're doing. Okay, so when I get to this point and I keep on dividing and multiplying, I'm not getting there. I'm going to go back to my original expression and see, did I miss a common factor? And as I'm dividing on my calculator, I notice that 3 goes into 105. So we could have taken out a 3 in the very beginning to leave us with negative 8x squared plus 35x minus 12. Now let's try our AC again. Should be a lot easier with smaller numbers. So A times C is going to be 12 times 8, which is 96. Now let's look at factors of 96. So 96 is 1 times 96, and we're trying to get to 35. Or it's 48 times 2. That's not going to get us to 35. Or it's 3 times 32. Well, 3 plus 32 is definitely 35. So now we're going to rewrite the expression and expand the middle term. So negative 8x squared plus 3x plus 32x minus 12. Well, I see that there's a common factor of an 8 here and here, and a common factor of a 3 here and here. Let's regroup. And that's going to become 3 times negative 8x squared plus 32x plus 3x minus 12. Now inside that group, I'm going to make 2 separate groups and factor that by grouping. Now this 3 is just going to come along on the outside. So right here, the first one, I can take out an 8x. And it's always a good idea, if that first term is negative, to take out a negative. So negative 8x will come out, and it becomes x minus 4. And then the second group, I'm going to take out a 3. So the 3 comes out and leaves me with x minus 4. Now you see I have a common factor. So the x minus 4 is going to have to come out, leaving me with negative 8x plus 3 inside. So that's 2 methods, AC method, or you can kind of use FOIL in reverse or your double distributive in reverse and check all of your possibilities. To me, the AC method is easier. Where people mess up is they forget to expand the middle term first. Once you have that expanded, you should by now understand how to factor by grouping and then bring out that common binomial. So that should get you through 5-2 factor trinomials. And I know the title is incorrect. And good luck.